Hello, Algebra 1 block. This is Ms. Bartels teaching you today's lesson on multiplying radicals. But before we get started, the last 2 days you've been working on adding and subtracting radicals. So why don't we warm up by doing a few of those problems. Go ahead and take out a piece of paper right now and write those 2 problems down. Pause the video here to give them a try. Okay, let's see how we did. Well, the first thing I notice is our radicands are the same. Therefore, we can go ahead and subtract our coefficients. So 7 minus 2 gives us 5, and you keep that radical the same. So 5 root 3 would be our answer. Okay, let's move on to number 2. Same thing goes with addition. Our radicands are the same, so we can go ahead and add our coefficients. 2 plus 4 gives us 6, and we're left with that root 2. Okay. Let's move on and do a quick review on the parts of a radical. Now you heard me mentioning what this was called, and that's a radicand. And what we call this check mark looking thing is a radical symbol or a radical sign. You'll hear me say both. Okay? And what you've heard of the past 2 days is what this 3 is called. This 3 is known as your index. Now, within multiplication, you will not see any index being used because that is a whole different topic. So you won't be seeing any of those within the next 2 days. And lastly, we have this 2, and it's a word you should have already heard before, and that is coefficients. You heard it during polynomials. Okay, let's see if I can move that. There we go, move the arrow with it. Nah, you get it. Okay, now that we have our vocab down, let's move on to the multiplication property. All the multiplication property tells us is that when you have 2 different radicands, you can multiply them together. That's it. So let's do a quick example. If we have a radicand of 5 and a radicand of 3, all we have to do is multiply those 2 together. So 5 times 3 is root 15. And root 15 cannot be simplified any further. So that would be our answer. Now, that was a simple problem. But what happens when I add in a coefficient? What changes? Well, nothing really changes. It's still the same method as adding and subtracting. The only thing is we're doing multiplication. So remember, there's a 1 in front of every radical if there's not a number there, if there's not a coefficient. So we just multiply our coefficients, and 5 times 1 gives us 5. And then we multiply our radicands. It does not matter if they're like. We still can multiply them. 8 times 2 gives us 16. Now, 5 root 16 is our answer, but we have to simplify it. So let's go back to our simplification. What are 2 numbers that multiply to be 16? Well, I know 4 times 4 will multiply to be 16 because the root 16 is a perfect square. So there's our pair. Remember, when you make a pair, you take that number out. And don't forget, you still have to bring that 5 down. You can't forget it's there. Now 5 times 4 is 20. That's our final answer. If you were to type this exactly into your calculator, you should get 20 because that square root 16 is that perfect square. Okay, let's move on to some practice. Go ahead and take a moment, pause the video here to write down all 6 of these questions on a piece of paper. Okay, let's go through it. Let's do the first one together. 5 times 4 gives us 20. So now we have to simplify that. What are two numbers that multiply to be 20? Well, the first thing I think of is 10 and 2. 10 can be reduced more. 10 can be multiplied by 5 and 2. So there's our pair. We made a pair of 2's. So remember, whatever your pair is goes on the outside, and whatever's left alone stays on the inside. Sorry, that was written really poorly. There's our final answer, 2 root 5. Okay, I want you to pause the video here and try number 2 on your own. Okay, let's see how we did. 3 times 2 gives us 6, and 4 times 2 gives us 8. Now we're not done yet because we have to simplify this 8. That can be split up into 4 and 2, and then 4 can be reduced more into 2 and 2. Now we made our pair. Now remember, just because there's 3 of them, they have to have a partner. So 2 cannot be circled. This extra 2, this third 2 cannot be circled because it does not have a partner. Remember, whatever you circled goes on the outside, and whatever you didn't circle stays on the inside. Now don't forget, this 6 exists, so we have to multiply the front, the coefficient, by 6. 6 times 2 gives us that 12 root 2. It's our final answer. Okay, let's do the same for 3. Pause the video here if you would like to give it a try on your own. Remember, there is a 1 in front of the radical if there is not a number there, if there is not a coefficient. Multiply what's on the outside. 5 times 1 is 5. And multiply what's on the inside. 6 times 2 is 12. Now we simplify from there. Two numbers that multiply to be 12. Let's go with 6 and 2. Two numbers that multiply to be 6. Let's go with 3 and 2. Now that's as far as we can go. All of these numbers are prime. But we did make a pair of 2's. And this 3 will be left alone. So again, don't forget the 5's there. That goes on the outside, and you have to multiply it by your pair. So our pair is 2, and root 3 stays on the inside. 5 times 2 gives us 10, root 3. Okay, on to the next. Look, now we have a negative, so don't forget that negative is there, and we still have to multiply it. So now we have negative 3 times 3, which gives us a negative 9. And 2 times 2 gives us 4. Square root of 4 is going to be a perfect square. It splits up into 2 and 2, which is a pair right away. So remember, when we make a pair, we bring it on the outside, and we're left with negative 9 times 2, because you have to bring that negative 9 down. And negative 9 times 2 is a negative 18. Okay, 2 more. Okay, again, this negative is there, so don't forget it's there. It doesn't change anything other than you're multiplying by a negative. So 2 times negative 5 is negative 10. 3 times 4 is 12. Let's simplify. Oops. 12 can be split up into, let's stick with the 6 and 2. 6, actually, let's go back. We did 6 and 2 last time. I'm going to switch it to 4 and 3 to show that you can still get the same answer. 4 can then be split up into 2 and 2. So here's our pair. So you're left with that negative 10 times the pair of 2 with the root 3. Negative 10 times 2 is negative 20 root 3. Now, real quick, I want you to make a connection. If you notice, let's switch the colors. We had to simplify root 12 right here. And we split it up into 6 and 2. Didn't we still get 2 root 3? And if we go down here, we were simplifying square root 12 again. And we split it up into 4 and 3. And that still gave us that 2 root 3. So no matter what two numbers you choose, it's going to give you the same answer in the end. Okay. Last one. Square root 12 times square root 12. Well, 12 times 12 is 144. And you're probably thinking, wow, that's a big number. Well, 144 is a perfect square, and it could be split up into 12 and 12. So your final answer is just 12. Now, if you see that square root 144 and you don't think you can recognize that right away, let's see what happens when we take the long route. We still will get the same answer. Let's see. Let's just keep dividing by 2, because that's the longest route we can take. So we have 72 and 2. Then 72 can be split up even more into 36 and 2. Well, we have one pair of 2's right here. 36 then can be split up into 18 and 2. 18 can be split up into 9 and 2. We made another pair of 2's. And 9 can be split up into 3 and 3. So we have a pair of 3's. Okay, so now you're thinking like, that is a lot. Well, let's go through and write our pairs down. So we have our pairs of 2, so that's 2. We have this pair of 2's, so that's 2. And we have this pair of 3's, so that's 3. 2 times 2 times 3 will give us 12. So no matter what route you take, whether it's this short route here or this long route here, you should get the same answer in the end. Okay, let's see if you can get them on your own. I want you to pause the video here and write these down. Go ahead and give these a try on your own, and then we'll reveal the answers to see how you did. Okay. Go ahead and pause the video so you can take a look at the answers to these questions and see if you did it good. If not, feel free to reach out to any of your teachers to ask more questions if you have any. Thanks for listening.